Hey cosmic explorers! Ever looked up at the night sky, at all those twinkling stars and distant galaxies, and wondered, will it ever end? Not just our sun, or our galaxy, but the entire universe itself? It's a question that's fascinated scientists and philosophers for centuries, and while we don't have a definitive answer yet, modern cosmology has given us some pretty wild and mind-bending theories. Today, we're diving into the ultimate existential question: how will the universe end? Get ready for some cosmic doom scenarios, but don't worry, it's all super far in the future. First things first, our universe isn't static. It's actually expanding, and has been ever since the Big Bang. Imagine baking a raisin bread. As the dough rises, the raisins move further apart from each other, even though they aren't moving through the dough itself. That's kinda like how galaxies are moving apart. This expansion was discovered by Edwin Hubble back in the 1920s, and it's one of the foundational pillars of modern cosmology. But here's the kicker: this expansion isn't slowing down, it's actually speeding up. Which is pretty wild, by the way. Let's kick off with one of the older, but still fascinating, theories, the Big Crunch. This idea suggests that if there's enough matter in the universe, gravity, that fundamental force pulling everything together, would eventually win out over the universe's expansion. Think of throwing a ball up into the air, it goes up, slows down, and then eventually falls back down. In this scenario, the universe would stop expanding, then reverse course, contracting faster and faster until all matter, energy, and spacetime itself collapses back into an incredibly hot, dense singularity, much like the Big Bang in reverse. Before we get to our next ending theory, we need a quick detour into a crucial concept: entropy. Simply put, entropy is a measure of disorder or randomness in a system. The universe naturally tends towards higher entropy, meaning things spread out and become more disordered over time. Think about a perfectly neat room. It takes effort to keep it that way, right? Leave it alone, and it naturally gets messy. Or an ice cube, it melts, spreading its coldness into the warmer water, reaching a uniform temperature. This tendency for energy to spread out and systems to become less structured is key to understanding the next cosmic end. This brings us to perhaps the most widely accepted theory for the universe's ultimate fate, the Big Freeze, also known as heat death. If the universe continues to expand indefinitely, and as we saw, it's accelerating, then everything will eventually spread so far apart that the universe will run out of usable energy. Stars will burn out, black holes will evaporate through Hawking radiation, and the remaining particles will be so incredibly distant from each other that no interactions can occur. The universe would become a cold, dark, incredibly dilute, and utterly uniform expanse where nothing ever happens. Total stillness, total cold, total quiet. A truly bleak prospect. But wait, there's a cosmic twist. Remember how I mentioned the universe's expansion is accelerating? That's thanks to a mysterious force called dark energy. We don't fully understand it, but it seems to be an intrinsic property of space itself, causing it to expand faster and faster. It's like an invisible, repulsive pressure that's pushing everything apart, constantly overcoming gravity on large scales. Dark energy is a game changer because it means the Big Crunch is unlikely, unless its properties change dramatically. Instead, it strengthens the case for an open, ever-expanding universe, leading to our next, even more dramatic, ending. If dark energy continues to dominate and its repulsive force keeps getting stronger, we could face the Big Rip. This isn't just about galaxies moving apart, it's about space itself expanding so rapidly that eventually, even gravity's hold on galaxies will be ripped apart. Then, solar systems, then planets, then even individual atoms will be torn asunder as space expands within them. The very fabric of spacetime would unravel, and everything, down to the smallest subatomic particles, would be isolated and destroyed in a catastrophic, infinitely fast expansion. Talk about a dramatic exit. Now, let's explore a more cyclical, perhaps hopeful, alternative, the Big Bounce. This theory suggests that the Big Bang wasn't the beginning of everything, but rather a rebound from a previous universe's Big Crunch. So, instead of ending in a cold freeze or a violent rip, the universe could be an eternal cycle of expansion and contraction. Each big crunch would lead to a big bang, creating a new universe with new laws, new physics, and new possibilities. It's a fascinating idea that suggests our universe might just be one in an endless series of cosmic breaths, perpetually born, dying, and being reborn. It's easy to get a little overwhelmed by these cosmic doomsday scenarios, but remember, we're talking about timescales that are almost impossible for us to grasp. Billions, even trillions, of years into the future. Our own sun still has about 5 billion years left before it becomes a red giant. Humanity, and indeed all life on Earth, will likely be long gone by the time any of these universe-ending events even begin to manifest. These theories are a testament to our curiosity, our drive to understand not just our place in the cosmos, but the cosmos itself, from beginning to potential end. So, whether it's a cold, silent fade to black, a violent cosmic shredding, or a perpetual cycle of rebirth, the universe has some dramatic finales in store. While the big freeze, heat death, is currently the most favored by scientists, the truth is, we're still gathering clues. Each new discovery about dark energy, black holes, or even quantum gravity could completely change our understanding. But isn't that what makes science so exciting? The journey of discovery, even when it leads to questions about the end of everything, is what truly defines our human spirit. What do you think is the most likely end? Let us know in the comments below.